Look, I'm just a geologist. I like rocks. I love rocks.
All right. Hello, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hello, everyone. I am Chris.
Yes. Hello, I'm Jesse.
Yes.
You rang.
Well, I feel like you just jumped into that. There was no warning that we were starting.
I said, I'm ready. Here we go.
You didn't inquire if the rest of us were ready.
Sorry, I did just jump right in.
We move
So,
on. This time.
hello, everyone. Welcome.
I was waiting for my Wayne's World countdown.
Yes. That's what we usually do, folks, for the behind-the-scenes people, you know.
Since we've done that every episode since last week.
Yeah.
He's right. I mean,
is this episode 70?
it's episode 70. Yes.
Crazy. Who would have thought 69 episodes we'd still be doing this?
What's 70? The Platinum Jubilee?
I don't know. I don't know if there's any significance for that one.
There's a
75, I would imagine, right? But I don't know about 70.
75 is the diamond?
Diamond, yeah, Platinum Jubilee.
Wow, I'm impressed you pulled that out of your tuchus.
Yeah.
That's awesome.
That is a very impressive feat right there. Whew.
That's what I bring. That's those fun facts.
Yeah. Speaking of fun facts, let's thank our sponsor, the Formatting Formula. So formattingformula.com or YouTube/C/formatting formula. And surprisingly, this week, I actually did not contact the Formatting Formula.
Is everything okay? Is there a communication breakdown? I don't know.
Well, I mean, honestly, I feel like the last 4 or 5 episodes in a row, I talked about how I actually contacted the Formatting Formula. And I was beginning to realize, wow, I really do contact them a lot because they're awesome. They just answer my questions right away. They fix my blunders instantly and make everything right in the world. So I can't say enough about them. And on maybe what it is I'm watching enough of their YouTube videos that I'm learning myself. It's like teach a man to fish kind of moment.
Sure.
So anyway, please check them out. And more than that, tell them the Geology Flannelcast sent you. They can fix all of your Microsoft Word formatting needs, anything from fixing your table of contents to embedding figures to customizing your toolbars at the top, anything. I've even customized mine a little bit to add a back button. So if you control click to go somewhere in your table of contents, you hit this little button, and it brings you right back. It's fantastic.
Bat button at first. It shines the button.
Yes. I hit that button and then the formatting formula comes straight to my house.
A hell of a service right there.
Yeah, that's the Diamond Jubilee package that they have available. But also, you get a slight discount on that if you tell them the Geology Flannelcast. So that's not true. But anyway, please check them out. YouTube/C/formatting formula or formattingformula.com.
Well, all right. So welcome once again, everyone. If this is your first time tuning in to the Geology Flannelcast, hey, what's up? We're here. We talk about geology once a week. And today we are covering our listener questions episode. I want to say, is this the 6th time or the 6th listener questions episode?
You could say any number, and I would agree.
Oh, there we go. We
listener
did one,
question 1, listener question 2.
Well, the last one we did was right when we first came back.
Yeah.
Yes.
Did a live one, yeah.
In May or something.
Yeah. So I think listener question 4 was in 2015, and then So we did one in May. It was 5, so this would be 6.
6. All right. So what we do is
counting to 6.
Everyone, this is actually the fastest that we've ever done a listener question episode. Since what's it? The turnaround, I guess. The last one was June, July, August, 6 months ago.
Well, yes, considering between 4 and 5 was 5 years.
Yeah, exactly. That's what I'm saying. We'll get to your question. Don't worry. It's geologically speaking, it's nothing. Okay, so 5 years. So we got if you have any list, if you have a question, if a burning geological question you'd like to have us answer on the podcast, send it over. We'll talk more about that. You just go to our website, geologyflannelcast.com. We'll give you the instructions at the towards the end on how to do that. But if you just go to the website, you can figure it out pretty easily. So yeah, so we got this list of listener questions, and so let's should we just jump right into it?
Sure.
All right.
I mean, that's what we're doing, right?
That's it. That's what we got for today. So
all right, I'm in. Sold.
all right. All right. So the first one, which one do you guys want to do first? You want to do the Mary Anning one first?
Yeah, why not?
All right. So first question was kind of just someone shooting an email. This is from Samueli. Doesn't say where that person's from, but anyways, he said this is a good topic for you. Have you ever talked about her? And this is in regards to Mary Anning. So actually, thank you for sending this along. Now Jesse's heard of this lady. I actually did not. I was not aware of this lady until I clicked on the link and started reading about Mary Anning. So she's kind of in the media right now. There is a movie. I think it just came out very recently.
I think either
Ammonite.
Ammonite. Yeah, if it's not out, it's imminently coming out.
Okay, so Kate Winslet plays Mary Anning, and so if you guys want to, I'll give the brief rundown. If you guys want to, feel free to jump in whenever you want with this. But
Yeah.
Mary Anning was basically a badass paleontologist back in her day. She was doing her thing in kind of like the earlier 1800s. And she discovered she was in England, and she kind of had a rough life, and her father died when she was young. And what her family did was they would collect fossils and they'd sell these fossils, and that's kind of how they made their living. But she found some really, really neat stuff. And she contributed to the first described ichthyosaurus. Is that how or was that it? Right?
Yeah.
Yeah.
Sure.
Ichthyosaur. Sorry. So it's a
Ichthyosaurus.
ichthyosaurus. And that's a marine reptile, correct?
Yes.
Okay.
It's yeah, I don't even know if reptile. Well, yeah, I would say yes. It's a marine.
Yeah.
Swimmy thing.
Yeah.
Yeah.
It's a very good explanation right there. So
Yeah. I'm sorry that I got too technical.
So her brother discovered the skull of this thing, and she later discovered the body. So they basically, I don't know, it seems from reading it that they found, if it wasn't a full body fossil, it was really, really close to discovering a full body fossil. So if you're a paleontologist and you find a full body fossil for one of these big animals, like I always tell people, just like, drop the mic. That's it. Like you're not going to walk away, retire at that moment. You're not going to find anything better than a it's so rare to find a full body fossil. So she was in Dorset, England. It's in Southwest England.
Yeah.
And she would just kind of scurry along the cliffs there. And
so it was, the area exactly was Lyme Regis, which is sort of a famous fossil site, obviously.
mm-hmm.
But you have these alternating, it's just these huge cliffs. It's the south of England. So you have these cliffs, and it's alternating, what is it, like shale and siltstone.
Some limestones in there.
Limestone, yeah. So it's argillaceous sort of material, so like clay. But you have these alternating layers, and so it's just the marine, sort of the ocean, sea level going up and down, creating these layers, and the layers actually correspond with Milankovitch cycles.
Nice.
What?
These transgressive, regressive cycles.
You got it. So, they are. Do you know the age? I would assume Mesozoic, because you're getting the authorities.
you know,
Yeah,
in
it's
this
a
brief
Mesozoic.
article, it says 200 million years, but
Yeah, so that'd be Mesozoic.
Was,
Um,
Jurassic, I guess.
so actually, wow. So like we said, if you find a full body fossil that's like huge, she also was involved with finding the first two nearly complete plesiosaur skeletons. So wow, that's
Yeah.
good for her. Good for her. So plesiosaurs are there are other marine reptiles. They had like the really long, skinny neck, and they look pretty goofy looking. They had these like four paddles, or they kind of just swam around.
they also swim.
Thank you. Hence the marine reptile. I was also reading. She discovered. In belemnite fossil. So if you've never heard of a belemnite fossil, belemnites is a type of mollusk, and when they get fossilized, they look like little bullets actually.
Mm-hmm.
And she found that they had little ink sacs in them, just like modern cephalopods, like squids, octopi. So this lady was just all over the place in terms of just being like a OG geology rock star, paleontology rock star. So like I said, unfortunately though, she lived a really, really, really tough life, pretty much in poverty her whole life, and just she tried to just make a living just selling fossils.
Yeah. And when she found that almost full-bodied fossil, she was 12.
Good for her.
Like,
That's
like that-
amazing.
But that was her job, though. Her job was just to dig up fossils by hand and sell them, like by hand, which is not easy.
So the other thing that they would do is, when the best time of year to go fossil hunting was in the winter time. So I guess the winter storms would erode away the cliffs, and the cliffs would just crumble. You'd have these like this mass wasting, the cliffs falling apart, and what it would do is it would expose the new fossils. But it was really dangerous because that rock it's falling apart. It's pretty sketchy, and she almost got killed. Actually, luckily she didn't get killed by the cliffs essentially just crumbling, but it took out her dog, and that's a really sad story. Yeah. It just I guess a boulder fell from the cliff and just missed her, but she had a little cocker spaniel or something she loved. So sad story.
She she became really well known for being able to find these fossils, and for her work, like you were saying, the ink sac thing. Did you mention she dissected modern cuttlefish to understand how modern these modern sort of squid-like things looked on the inside, to think about how the fossils she found related.
Oh,
wow.
Yeah. Cool.
That's insane.
Yeah, she would correspond with Charles Lyell,
another like giant in geology.
Yeah.
She was well known. There was a few other people who would, like, sort of famous people. Louis Agassiz, who's the famous sort of glacial geologist, Swiss glacial geologist, would actually go visit her to have her show her around the cliffs. And the Ammonite movie is based on the relationship with her and Charlotte Murchison, who in her own right was a respected geologist. And Charlotte Murchison was married to Roderick Murchison. And so if you know, the Murchison crater on the moon is named after him. He was also a famous geologist.
No kidding. The name sounded familiar, but how about that?
Yeah, so there's all these sort of connections, especially you get back, because she lived, the early 1800s. I feel like that's when they were all palling around. She Adam Sedgwick was an early geologist who would visit her and was one of her early customers. Adam Sedgwick taught geology at Cambridge, and one of his students, Charles Darwin. So
Crazy.
Yeah.
Yeah, I feel like we should do a whole episode on famous female geologists.
We should loop back around and do one on her. Yeah, there's a bunch here.
Yeah.
So there's here's something that you guys may not have realized. The tongue twister, I see, I can't even say it.
Yeah. This is what
She sells
seashells by the
down
seashore.
by the seashore.
That was supposedly written about
Mhm.
her as well.
I'd call him BS on that one. But
Wow.
I take that with a grain of salt, but may or may not.
She sells ammonites down by the seashore. It just it doesn't work.
Anning is aware of ammonites along
The abutment. Anyway. Yeah, very, very cool. I'm interested in that movie. I'm gonna check it out as soon as it hits one of my streaming services.
She's definitely one of those characters who I knew about, and I kind of want to go back and dig a little more into her life because it looks like a really fascinating.
Yeah, because I think she only lived to like the age 48 or 49.
Yeah, 47. Yeah.
Bummer.
Yeah. So, but yeah, real
Rock and roll. What can I say? She lived.
Mary Anning, true rock star back in her day.
Boy.
OG.
Cool.
Yeah.
Great.
So, all right, cool. So thanks to Samueli for sending us that.
Yeah, we'll come back to her because I feel like there's a lot more to her story. So.
Yeah. All right. So the next question. Let's see. Let's do this one. Sarah from King George, Virginia. She sent us a link to this website. She goes, "What do you guys think causes this? It's weird." So of course we love weird things here at the Geology Flannelcast. It's kind of what we live for. So of course I saw that and I was like, all right, I gotta check this out. So she sent a link to this website on Popular Mechanics, and the title of the website is "Earth Keeps Pulsating Every 26 Seconds. No one knows why." All right, so let's dive into this. Let's see.
Always like when they do that, when they throw that out there.
No one knows why. You know what?
Scientists don't know.
This title is a little clickbaity, all right, because they give some explanations on why it happens, if you read through it. So, thank you, clickbait. So, let's see. There's the Earth is pulsing every 26 seconds, and scientists can't explain it after 60 years. So back in the 1960s, a geologist by the name of Jack Oliver first documented this pulse, and he called it a microseism. And so Oliver was at Lamont Doherty at Columbia University, and they could detect the noise, but essentially, I guess they didn't have the equipment that modern seismologists have in their arsenal to really dive into this and figure out what's causing the Earth to pulse every 26 seconds. Well, it turns out that they kind of pinpointed where this pulse is coming from, and it's coming from a part of the Gulf of Guinea called the Bight of Bonny. All right.
Huh.
And so there's two. The article says that there's two possible. They're saying that there's two causes for this pulse every 26 seconds. So the first cause is, I guess not the cause. The first hypothesis, right, is that it's coming from waves slamming or beating into the continental shelf. Right?
Always is.
There we go. Right. So in case you're not familiar with the continental shelf is, the continental shelf is part of the continent that's submerged. It's usually less than about 200 meters depth of water. It's relatively shallow. We're not talking about like something that's tens of thousands of feet deep, like the abyssal plain, a couple hundred feet deep. And So the first hypothesis, so this extends out coming off the continents. It's basically just the flooded out part of the continents. And the first hypothesis is that waves are slamming into this, and that's what the pulse is. The second hypothesis that this website explains or kind of talks about is that it's just kind of from volcanism, a nearby volcano. There's a volcano right there, and they say it could be from the volcano. So this has been documented in a volcano in Japan. They had a similar pulse coming from this. So I guess the question is, what do we think is causing this? So the first thing that that kind of came to my mind was the Taos hum. This kind of is similar to the Taos hum. So
My favorite. It's my favorite of all the hums.
Jesse's favorite hum. So, Jesse, can you explain to the listeners what the Taos hum is?
Well, it depends on whether or not you believe in the Taos hum. And I sort of feel like the Taos hum is like, you can't talk about the Taos hum.
Yeah.
But the Taos
Well,
hum,
we're going to talk about it because this is the podcast where we will cover the topics that no one else dares to cover.
I was just going to say, I was sitting by the old backyard campfire the other day with Sasquatch, and we were talking about the Taos hum.
So Taos,
Rubbing my healing crystals.
Taos is in New Mexico. It's like north of Albuquerque. And people have been reporting since at least, I don't know, for the past 40 years probably, that they hear this really low, sort of low frequency hum. I don't know how else to describe it.
Hence the Taos hum.
What's that?
Hence the Taos hum. That's where
they did a survey of residents a couple of years ago, and 2% of the population said they could hear it. So not everyone can hear it.
No.
And it's like a super low frequency sound. Yeah. I guess that's where the hum thing comes in from, right?
Yeah. So that's part of it. Like, you know, everyone's hearing is different, obviously, and but some people, the range at which they can hear, and it's sort of like the idea where the kids can hear a different frequency range than adults.
Yeah, like they can hear higher pitches. And
have you ever heard they use that as a deterrent to keep young kids out?
Convenience stores. And
Yeah. So as you get older, you can I guess it's the high pitched noise. You start
to. Yes, higher frequency. Yeah.
Yeah, and it's like it's just your age. As you age, you just can't hear the high.
I've heard the kids have used it in reverse too, where there's apps that can make these noises that they'll play in class that they can hear, but the teacher can't.
So they're torturing themselves while they're in class?
Or it just gets in a good chuckle.
Yeah.
You know, it's always, you know, they like to be in on a secret, I guess.
You can actually go to websites and they'll play, you know, you type in your age and it'll play frequencies and, you know, and yeah, you can't hear them.
I mean, think about like when you do a hearing test, that's part of it. Like you're getting a certain frequency because they can tell how your hearing is, if you can hear those frequencies or not.
Yeah, I have a fun little quick story about hearing tests. I went to get my, I have my OSHA 40-hour certification. So once a year you have to get medical monitoring. So part of that is hearing tests. So I'm in the booth this year and I'm sitting in there, and usually it starts kind of quiet and then it gets quieter and quieter and quieter and higher frequency and higher frequency and higher frequency. And I'm in there and it's getting louder and louder. And I'm in that little soundproof booth hitting this button and like it's screaming in my ear and I'm like flinching, hitting this button, and the nurse comes in, she's like, "What, can you not hear that?" I was like, "I can, I'm hitting the button." She's like, "Oh, I forgot to plug the little thing in."
It was feedback?
No, she forgot to plug my buzzer in. normally you hit the buzzer
I see,
and then it goes quieter and quieter and quieter, and they get to the point where you can't hear it anymore. And she's like, "Oh my God, this guy's deaf." Well, so now they just been bombarding my left ear with all this super loud noises. And they're like, "Okay, we're gonna have to restart it." And I'm like, "Now I can't hear anything out of my left ear because it was so loud." It was like trying to take a hearing test after coming out of a concert.
And that's how Steve got his hearing aid.
No, well, it's funny. At the end of my exam, they screwed up my eye exam too. But at the end of my exam, the doctor's like, I'll sign off on this, but you should really get this checked up. Like, you can't hear or see."
You go to Dr. Nick from The Simpsons?
Yeah, exactly. Hey, everybody. Yeah. So, fun times.
So, one of the explanations for the Taos hum is that it's ocean currents basically resonating against the Gulf of California, where you have the Baja Peninsula and you have Mexico proper. And so it creates this big U shape. And so the currents hitting off that create this essential ringing that for whatever reason goes through the lithosphere and, I don't know, pops up in Taos. Taos is 1,200 miles away from the Gulf of California.
So,
I mean,
it's like a giant tuning fork. And
yeah,
Taos is the end of the tuning fork.
I'd need to see the structural geology to see if it made sense. If all of the geology is just really flat, and for whatever reason it folds up right there, 1,200 miles.
It doesn't even fold. It's a tiny little pinpoint area that it comes up. Right.
Yeah, it just
funnels.
It's
not even that it's following a certain strata or something like that. It's just going right to Taos.
Yeah. Meanwhile, there's a government facility buried underground.
But like you were saying, they've have seismometers, and they've sort of known about this. They have seismometers on the bottom of the ocean, and they've always noticed this sort of basically hum or frequency within the earth with all of these seafloor seismometers. And they only very recent, they've sort of known about it since the 50s, but only recently have really looked at all of the data and sort of put it together and and figured out that the earth sort of has a natural vibration to it. And so the earth itself vibrates between, I've got the numbers here, I pulled them up for you.
Look at this.
Between 2.9 and 4.5 millihertz. So it's a frequency that's 10,000 times lower than basically what we can hear, considering our hearing threshold starts at 20 hertz.
Yes.
So 4.5 millihertz is less. Whether or not that has anything to do with the Taos hum or this is sort of interesting. It might just, like you were saying, these areas where things you sort of just focus it a bit.
Yeah,
that might be driving it. But
that's interesting. I never heard that study about the natural frequency of the Earth. Everything though has a natural frequency, a natural vibrational frequency to it, though.
Yeah, and if you figure, it's called free oscillation, and so it's not super well understood because it's tough to study the whole Earth. There's some thought that it's a side effect of just the constant currents of the ocean pushing back and forth. Some other thought that it's atmospheric wind motion, but wind moves.
Yeah, so variable.
Yeah,
it's not regular at all.
Really low density, and it moves pretty slowly relative to, the power relative to waves is.
But the irregularity of it too.
Yeah, that's true. I think it's just
so
an energy. Yeah, I guess it's probably canceling, and I wonder if it's just the Gulf of California is a place where you're getting sort of constructive interference or something like that into the lithosphere.
So
constructive interference. That was my nickname in high school.
That's destructive.
So I guess to take it back to the area with the the original question with this.
Yeah, what were we talking about?
The tau saw.
No, this frequency that happens every
this-
26 seconds.
Yeah, the Gulf of Guinea, was it?
Yes, somewhere off Guinea.
Yeah. I have all these tabs open. I'm trying to find the tab. So it's every 26 seconds. So in terms of waves, so what we call what you call the amount of time it takes for each wave to hit, it's called the period. All right. So wave period. So basically how many seconds in between each wave. So I don't know if it's different around there, but and then also if that's where I'm kind of just thinking out loud with this, but the wave period on the East Coast of the United States is like basically like 10-ish seconds. Every 10 seconds you have I think it's like 8 to 10 seconds off the top of my head. You have a wave coming in. So this is potentially 3 times or nearly 3 times more than what we have on now it might be different. I don't know, but so that's just kind of what I'm thinking about right now in terms of waves and how how that could be related. But maybe it has something to do with like deep water swells, and they could be distance out further apart. You could potentially have a longer period with the deep water swells.
Yeah. It's interesting. Maddie, our on Patreon, just sent us a little XKCD comic that talks about this. It's kind of funny. Good chuckle. But it brought up a point that I wasn't even thinking about, because it shows a map. So it's in the Gulf of Guinea.
Yeah.
Okay. Not actually Guinea. So
the Gulf.
Guinea, the country, is separate. Is not on the Gulf of Guinea. It's Guinea. The country is north of the Gulf of Guinea. The Gulf of Guinea is in the part of Africa. So it's almost like the Gulf of California, where you're coming into this sort of semi-rounded part of the continent.
Mm-hmm.
I wonder.
So we need to find the Taos equivalent of, or did they find the Taos equivalent?
Let's look. We'll just draw a circle 1,200 miles away, and it's somewhere on that circle.
Yeah.
We'll just have to. This is part of the Flannelcast World Tour. We'll go in and visit everywhere along that radius and see what
until we find something interesting. I'm in.
Just walking along. We'll have to learn all the local languages and to ask, do you guys hear anything? Does anyone hear it? We'll make it one night before the authorities lock us up.
We just need 2% of you to say yes.
Yeah, that's all right.
That's it. Oh man.
So the Gulf of Guinea is on Africa's west coast, kind of in that, I guess what Jesse was trying to explain, kind of that
the west coast sticky outy.
Yeah, where it narrows,
the part that goes in.
Yeah.
Directly opposite of the Horn. The Horn on the East Coast. It's like directly opposite that.
Right off, let's see, we have like Nigeria there, Cameroon.
Yeah, I guess I could have used more. Yeah.
Ghana, okay, Liberia, like that's
Togo,
yeah. So
Equatorial Guinea. Anywho, so
we never sent your geographers here at the Geology Flannelcast.
So if we have any listeners in the region, any listeners in Ghana or Togo or Benin or Nigeria or Cameroon, I'm just going to name them all. I want to cover the base. Equatorial Guinea or
anywhere within a 1,200 mile radius at that point.
Let us know. We're coming to visit Ivory Coast.
Yeah. And do you have a couch?
Yeah. We'll bring stickers. Flannelcast stickers.
Yes.
And
and some smiles.
Yeah. And
we'll teach you how to podcast.
And greetings from the formatting formula.
Yeah, exactly.
It's interesting. That's where they're detecting. It's got to be something with the waves resonating.
So That's what I think. I think that's the most obvious answer because the other explanation was from volcanics.
Yeah, and
And-
that was weird for the volcanics to be that.
Yeah, it didn't. The
regular?
website didn't say what was causing, what could have caused it in terms of the volcanics. So that's where I was kind of like,
And I don't know. Like
Unless-
we're talking about resonating energy, and if you have a large enough mass of hot rock, would that resonate? But even that, just it still seems a little far fetched.
Yeah, because I mean the rock itself, it's squishy and hot. Is it the movement of the magma that's just shaking the country rock?
but to have
Yeah.
something every 26 seconds. That's
And for the last, it was like 60 years or something, though.
yeah,
Um,
yeah. They picked it up in the 1960s.
yeah, they started putting the seismometers on the seafloor. Then that's 1958, Lamont Doherty.
Yeah.
Maddie also just sent this link with that comic. It's called the World Hum Map, and I guess
I'm looking at it right now.
where they found hums, and boy, is this fascinating. I want to travel to these places. Like, I don't need to go to like Delaware, but I want to go down to like,
Hey, nothing wrong with Delaware.
no, I like Delaware a lot, but I've been there enough. Like, I want to go down to Panama here and talk to this 37-year-old who first heard the hum in 1996.
How are you getting this? I'm not seeing this part of the
If you
website.
click on the dots, it gives you what they filled out. Oh, and it gives them anxiety.
Oh,
Wow.
Oh, there's one in Swedesboro. It's not far from me.
Huh.
What is your age? 51. Low frequency hum.
wow.
How much effort have you put into it? Some effort.
I'm looking at this map. Yeah, okay, I see now of where people are hearing the hum sound from. It just looks like the distribution of where a lot of people live in the United States.
I mean,
And I'm not seeing that many dots around Taos either. It's mostly everywhere else but Taos.
yeah, maybe
There's one. Okay, I see one dot in Taos.
Well, they keep it a secret.
Yeah, it's a government facility. I told you, Sasquatch told me.
Okay.
There's a lot
Anyway.
of Hawaii, which Hawaii I would ascribe to.
I would buy Hawaii,
Yeah, this is all over the place. Yeah, there's very little around the Gulf of Guinea. Huh. There's one in the ocean. There's the UK seems to be vibrating a lot.
But again, it takes people to hear it in order to report it.
That's the tree falls in the forest. This is it.
Yeah.
If the earth is humming.
Yeah, there is a lot in Western Europe. My next question is, Maddie, how did you find this?
Yeah, right. Like
That's the real.
we found our new Flannelcaster fact checker. Well, maybe not fact checker. I'm not sure. But
the other interesting thing is, yes,
researcher.
In China, there's only one place that has the hum, and that's Hong Kong.
Nope, they just took that dot off. It was the government.
No one heard the hum.
You heard nothing. I don't know why it's Schultz from.
I clicked on one from Finland, and their occupation is where it says like, "Do you work in loud environments?" And it's, "I'm a singer in a rock band." That might be tinnitus.
Yeah.
Elder millennial skills is what matters.
Yeah.
All right, we can click on this map all night, gentlemen.
Yeah.
We should
Let's,
do an episode just on this map here. This is
It's exciting podcasting, talking about what we're seeing.
yeah, that nobody else can see. Yeah.
Well, anyway, so we don't. I guess to wrap this question up. Number one, thank you to Sarah for sending this question and ruining my life for the next 3 weeks as I research this topic. But
yeah, and just like most of our listener questions, the answer is we don't know.
Oh no, it's the ocean.
I would lean towards I think the ocean's your most obvious answer. Unless if
I-
you're a volcanologist and you have an explanation for this,
Yeah,
shoot us an email on
exactly.
geologyflannelcast.com. Just click on contact us. Let us know.
Does-
Hit us up. Let us know your 2 cents.
I wonder if Loch Ness has a hum to it.
I mean,
I want to combine my conspiracy theories.
Yeah, exactly.
I want to bring Nessie into this.
and
as I
Roswell.
wanted-
Are you gonna bring Roswell into this?
Whew,
If
yeah,
we
maybe.
could, it'd be full circle.
Yeah.
I mean,
Uh,
New Mexico,
Stonehenge,
Taos, New Mexico.
How far is
Egypt.
Taos from Roswell?
Oh yeah, Towson Roswell. Okay, so, yeah.
There? I don't know. I'm not. Again, we're not geography people.
Geographiers.
Geographers. Oh no, they're pretty far away.
Geographiers.
What part of New Mexico is Roswell in?
Oh, there is a hum saga in Loch Ness.
The Roswell's in the southeast.
Wait, they're hearing hums and
Yeah, Ness hum
Ness-
saga is a global issue
They're
from the Highland News in 2008.
250 miles apart, Roswell and Taos.
Hmm.
Huh. Anywho,
That's within the error bar.
yeah, the grand scheme of the Earth.
Or is the Taos hum coming from Roswell?
don't start with this.
Then how close is that to Area 51 in Groom Lake?
I was just I wasn't gonna go there. I was
No,
thinking
I know
that
you were
in
thinking
my head, but I wasn't going there.
it's up in Nevada.
Oh man. Wow. So Sarah, I think is it consensus? We think it's from the ocean waves.
Yes.
Most likely explanation.
Yeah,
The motion
I mean,
of the ocean.
If you use
It's- it
Octan's
is-
razor, simplest explanation.
it's really interesting, and I would love to see, not only mapping up like the different shapes of the coastline, like the continental shelves there, but also like the underlying geology, how it's going to vibrate different rocks. We've got a lot of questions.
But also there's probably other factors too, like the nomogram, Chris. You know what I'm talking about?
Mhm.
It's this really awesome diagram that basically it tells you a lot of things, but it's like wave height versus wind duration versus fetch.
Oh,
like
yeah.
all
Yeah,
in
yeah,
one,
yeah.
all in one diagram. So I think how long the wind is blowing over the water for how far is going to play a factor too. So all these things need to be taken into account. I think that's why there hasn't been a simple answer in 60 years, because just a lot of variables.
Yeah, when you're dealing with waves, there are a lot of variables involved. But I don't have an answer for this 26-second pulse. I don't have a quick answer, at least.
Yeah.
So
Really come full circle.
yeah.
Wait, Sarah's got 2 questions on here.
Does she?
Oh, I was looking at the wrong one. I'm sorry.
Yes.
I was looking at Oh yeah. Oh, she does it. Okay. I see. Okay. Yeah.
Yeah, about Chicxulub.
Yeah.
All right. So I guess we could hit up Sarah's next question.
So her next, it's about Chicxulub, the Chicxulub impact. So there, we just drilled into Chicxulub recently, the international drilling program, and it's not the first time.
It won't be the last time.
It probably won't be the last, yeah. But she said everyone was like, dinosaurs died because of an asteroid, case closed. She started hearing grumbling from some people who are still on about volcanism causing the extinction. Do we have conclusive dating from the Deccan Trap timeline? I can actually answer that. Could the asteroid cause the volcanism? I never get a satisfactory answer from the articles I read. So one of the big proponents of the volcanism story, so you get a lot of volcanism that occurs at the same time as the extinction event, and so it's in India. It's these big flood basalts called the Deccan Traps, and they're massive.
Yeah.
It's 1,000-foot thick basalt layers. Um,
So it's 200,000 cubic miles.
yeah, whatever
That's ridiculousness.
So one of the big proponents of this,
I'm sorry, real fast. It's 6,600 feet thick.
Phew. So it's successive flows. It's not all at once. And the expert, the world expert on it, is a Princeton geologist named Gerda Keller, and she has done like incredible work. And one of the things she's done is really nail down the dates of the basalt flows. And basically, what they find is that the flows go across the boundary. They start a little bit before the impact event, and they go over the impact event, and they're occurring after the impact event. And so, because it's not just a single outpouring of lava, it's multiple flows over the course of like 1.5 million years.
So I have a question then for Sarah. She asked, could the impact cause the Deccan traps to start flowing? My question is, did the Deccan traps flowing change the gravitational pull of the Earth and cause the asteroid to hit us?
Hit the keyhole.
Telling you.
It's,
Threw off our wobble 0.5%, and there we go.
So when an asteroid's really close to our orbit, it's like a 0.5 degree of like that it has to be within the trajectory of the Earth. It's called the keyhole. Whether or not our gravity will pull it into us, or it'll just skip by.
Kind of like, you mean like when you have like a flat stone, you kind of skim it on the water?
Yeah, it's got to be just right. So
that was one of the fears with Apollo 13 when they were great movie with Tom Hanks, by the way. When they were coming in, they had to get the trajectory right because they were coming in too hot. And there was a fear they were going to skim right off, just like a flat stone, like I said, on a pond, skim right off the atmosphere of the Earth.
They thought they would have had more weight because they were supposed to have moon rocks.
Yeah.
So their initial calculation.
Oh, okay.
Light, or they were lighter than the initial. So I would say no, the asteroid didn't cause the volcanism because it was going on before this occurred. So there's dating that shows it's going on across, and the dating story is really interesting, and it's like incredible work, and it's sort of, in my mind, this is opinion. Can I throw opinion into it?
Sorry, just turn into Jesse's corner real fast. Go ahead.
It gets diluted the story, like the work gets diluted a little bit because they're always trying to draw the connection that it's the volcanism that is the driver of the extinction event. And I think just like the science of what they've done, just piecing the story of the volcanism together, stands on its own as really incredible work. And they've sort of revolutionized some ways in which you can date these flood basalts. And so I think it's really fascinating and really interesting stuff. But the asteroid really killed everything.
Yeah.
Yeah. I mean, would the dinosaurs have died off? It's a question mark, but
I think, wasn't there talk that, the dinosaurs were kind of on their way out?
Yeah.
It was kind of like the asteroid was a needle, or was it the straw that broke the camel's back?
Yeah, it's one of
but I think it's more like the boulder that broke the camel's back.
That burnt everybody alive as it collided into Earth.
But yeah, yes, the dinosaurs were evolving, things were changing, environments were changing. But then you smash a gigantic asteroid. Yeah, and I said it, asteroid, into the planet.
I'm not letting you bait me, all right? This one would be considered an asteroid.
Yeah, exactly. So listen, I'm team meteorite, but the asteroid hits the planet, that's it. There's no ifs, ands, or buts about it. Like that's what did it.
Yeah.
So there you go, Sarah. That's the answer. Stop reading articles right now. It's bad for you. I'm just kidding, but
I think it seems like the general consensus is that it was the asteroid, and every once in a while you'll hear a story pop up. Well, hey, maybe it was like the 1-2 punch or something like that, and like
Yeah.
I think just the general consensus is that it was the asteroid.
Yeah, that's the thing. Again, to switch analogies, it's like the 1-2 punch. If you were boxing someone and then all of a sudden someone came in with a bazooka, like.
Yeah. So, anyways, I think that hopefully that answers that question. You could sleep at night again. You've probably had a lot of sleepless nights just thinking about that.
I'm sure, man.
I do like how she wants to do her countertops in shocked quartz or something here.
That would be amazing.
Yeah.
She wants to finance for her new kitchen. Yeah. Good luck. That'd be awesome.
Yeah.
Are we skipping this next one? Name your worst nightmare. Where are you from? Don't worry about it.
We could skip that one. That's some troll that may or may not have been on the podcast many months ago.
I want to talk about my two favorite topics. Number 1, Bill Lucas. Number 2, soils of East Africa. So, sorry, Bill, we're going to have to pause on that one and do a little more research, and
Bill,
hopefully we'll get back to you.
If only you were just more polite about your question, and I would have answered it. But if you're going to be that rude, start your own podcast. All right. I love you. Okay. Which one you guys want to take next?
I don't know. Frank's got a good question, but I don't know the answer.
Yeah, I don't. Frank,
So I think Frank's listening right now too. So
I want to look into that. I'll get back to you.
Yeah. So
save that one because
Frank's a great friend of the podcast at Patreon. So we don't want to.
We don't
want to wing it.
I'll say the question, but I'm not going to attempt. It's unless you want to read it, Chris. I will.
No, go ahead.
Can you explain the Kula plate idea and the Baja de BC hypothesis? Why does the Pacific plate strip off pieces of the North American plate, and will it continue to do this? Unknown. I mean, we could probably tie in when we talked about that new plate that was just found.
Zealandia?
No, up north of Juan de Fuca there.
Oh,
that's subducted under. It's sort of like the Farallon.
The Kula? Wait.
Was that the Kula?
I thought that was the Kula plate.
Yeah.
Oh man, see,
because I made the fantastic joke about the Hada plate.
Question. Yeah, it's in the question too.
What's the other plate behind the Kula plate? No. Yeah, See, this is why I don't want to.
Man, if you guys aren't watching on YouTube, check us out on YouTube to watch the emotion that just ran through Jesse's face. It was like excitement, and then questioning, and then disappointment, and then happy, and then all within 2 seconds. So check us out on YouTube for that one.
Yeah. Oh man. No, the resurrection plate. That's
Oh, the resurrection.
Oh, resurrection plate.
Oh, okay.
Come on.
Because we have another question about the resurrection plate.
Yeah. Which let's just say we've covered it. We've done that. Done it already.
Yeah.
No, but we'll have to get back to that list of questions.
And Frank brought up about the Kula plate when we were talking about resurrection. That's why it's sticking out to me.
Gotcha.
I want to look into the Baja de BC hub. I don't know much about that.
What part of the North American plate is getting stripped off? Like, is it just from the friction of the two plates grinding up against each other? Because wouldn't that make sense if it just took off little chunks, like
I mean,
little by little?
if you're in the transform part of it, I suppose. But in the Pacific Northwest, I don't think you would. In the subduction zone part of it, because you're not going to subduct pieces of North America.
You're not going to subduct it, but wouldn't it? Couldn't it just
chunking up? No.
Oh, how far down would it? Well, the other question is, how far down would it go?
I don't know.
All the way.
Because theoretically, like, so say you have a pool float, right? You can push the pool float down to the bottom of the pool, but when you let go, it pops right back up. But could you get a situation where the force could just be so strong that it is taking that pool float down? And
I don't know if it's that. I think it gets ground up and becomes part of the melange, part of the accretionary prism. I don't know.
Accretionary prism, fancy guy.
Melange,
it'll always be a wedge to me.
So again,
yeah,
like I tell my students, I'll have to get back to you on that one.
All right.
Okay.
All
Well,
right.
let's go to this. Let's go down to Mark's question. So, hey, Mark, is Mark still listening? Let's see. Yeah, there he is. He's still on here. Mark sent us a question a little while ago, and there we go. He's very excited we're answering his question.
Good friend of the podcast.
Good friend of the podcast. Very generous Patreon friend of the podcast. Supporter. Okay, so he goes, my question pertains to the somewhat recent discovery of water molecules locked in the Earth's crust. How would one go about extracting the water from these rocks? As far as I know, the water exists as bond molecules, not
Bound.
liquid. Oh, bound. Sorry. So if we could bring that rock to the surface, would it be a process of smashing it, melting it to release water vapor? Would the journey to a low pressure zone cause it to escape? Could we even reach or bring that material to the surface? Sorry, that was a long walk.
So I guess I could dabble to try to answer this question, right?
Yeah, give it a shot.
Yeah.
You can have hydrated minerals at the surface. So you can have water molecules bound up in the molecular structure of a rock, mineral, what have you. So in order to liberate it, usually you have to add some sort of energy to the system.
Mm-hmm.
Now, usually when it's locked up in the crystal lattice, you can't just smash it. You usually have to heat it some sort to essentially start that chemical reaction to break it down. Does that make sense?
Yeah. You asking me?
Well, I'm just, just like
who are you asking?
You can like desiccate clays. You can put a clay in an oven and dry it out enough where it actually changes structure from.
I've done. It could also just be as simple as taking a piece of gypsum. So gypsum is a pretty common mineral. Its chemical formula is CaSO4 2H2O. So it has that water attached to it, and all you got to do is just get a lighter and just kind of burn the gypsum. You'll turn it into anhydrate right then and there.
Yeah. I mean, even like rocks like zeolite, you can actually.
Yeah, that's right. There's water in a lot of those.
Yeah, but
now the process of actually bringing it up from great depths, I don't know if that is enough of an energy change in itself to do it. I guess not.
Yeah. So
based on Jesse shaking his head, no.
Yeah. So basically, I mean, where they found these, if it's what I think he's talking about, is
ringwoodite.
Ringwoodite.
That's what. That's what I thought. Yeah.
Wadslite. Ugh. Come on with these names. And you find them in if you're familiar with if you've done your looking at seismic zones, like your physical geology class, think about where you see seismic zones where they show the classic, as you go deeper into the earth, the seismic waves go faster and then they slow down and go faster and so on and so forth. Between 410 and 660, you have what's called the transition zone, where you see like two little slowdown points.
410 and 660 kilometers.
Yeah, kilometers.
Okay.
Yeah, and that's basically where you find these minerals. but the water, it's not even, like, it's not liquid, it's not ice, it's water that's in a different structure. It's like, like when we talked earlier about in a previous episode about like ice 17 or whatever, where you could have, different structures. It's technically H2O, but it wouldn't be.
It's I guess, would that be considered a polymorph?
I don't know now.
I don't know.
That's polymorph is minerals, which are sort of phase dependent. You got to be solids. So it's basically just you have this H2O structure within the mineral itself, but it has this ability, the mineral, to just take on these H2O molecules. And that's why you probably saw headlines that said like ocean in the mantle or an ocean's worth of water.
Yeah, there's not like free flowing water in the Earth's mantle.
But it's a really
all
interesting,
locked up in minerals.
An interesting question, what would happen? Because at that depth, you're at, I don't know, 1,000 degrees Celsius or 1,500 degrees Celsius. What would happen if you brought it up? I'm wondering if the mineral itself would decompress, it would expand because it's under compression when it forms. I'm wondering if the H2O in it would lower the melting point and it would actually start to melt. Be interesting to compression melt.
Oh, I see.
Yeah, that phase diagram of what.
Yeah. I think
it's a really interesting sort of thought problem where I don't have the petrology or mineralogy know-how to.
Yeah.
So
that's more of what I was saying. I was saying more of, if you decompress the mineral, would you start getting like a partial melt?
Yeah.
And partial melt that would melt first would be the water. I don't know.
Yeah, that's really interesting. Yeah. I'm almost positive it wouldn't like turn into liquid or anything. Like you couldn't squeeze the water out of it.
So I should stop hoarding my ringwoodite.
Yeah.
I keep trying to turn it like it's a towel. Cutting up.
I don't think Poland Springs is going to buy that from you, all right?
Got this great. We just need to stick a well down. It's the way I try and get them to fund a really deep
core. Yeah.
So, by the way, completely off topic, but all of our Philadelphia accents were screaming for that last topic. Oh, the water.
The water locked up in the minerals. Yeah.
All right. So hopefully, I think that answers Mark's question, and which is a perfect segue to the last question. We cover this last one real fast.
Yeah. Aarons.
Yes.
Hey, Ron.
Or Aaron, as other people
Oh,
pronounce it. Aaron from Los Angeles. Hey. Let's see. Hello, new listener to the podcast, and I love listening to you fellows. I have been studying geology at community college and wanted to see if you guys be willing to cover partial melting, maybe tying it in with the talk about igneous rocks and how different conditions can create different types of rocks. Thank you. You guys rock. Oh, thank you, Aaron.
This ties in nicely.
Yeah. So look at that. Perfect segue. Thank you, Aaron, for helping us out with this perfect segue to this last question. Partial melting. So what does that mean? So it means it's exactly as it sounds. The rock only partially melts, right? And so there's actually rocks out there that are a product of this partial melting. They're called migmatites, right? You see them a lot in like gneisses, right? So gneiss is a metamorphic rock, and by the time you get to when you're making gneiss, or when gneiss is forming, I guess people don't actually make gneiss, but when gneiss is forming, it's at these really high temperature and pressure conditions. And so what can happen is, it's kind of like it's gneiss is kind of like end of the line for metamorphism for rocks. So sometimes the pressure and temperature conditions are so high that part of the rock starts to melt. And so when you look at these rocks called migmatites, you can actually see these little pockets of granite inside the gneiss, or all mixed in, I guess you'd say, with the gneiss. And what that is that's partial melting. So only part of the rock melted. You see this a lot. I saw this a lot actually in Rocky Mountain National Park. I was hiking out there and see these really, really nice migmatites. There's a lot of gneiss out there, and these little kind of like blobs of granite kind of mixed in with the rock there. So that's kind of your, I guess, real fast run through of partial melting.
Yeah, and if you want to go slightly deeper, you can go way back in the archives. Episode 18, we talk about Bowen's reaction series. So if you're taking a geology class, like an intro-ish level geology class, that would be a pretty good episode to listen to.
That's right. We did that episode.
Yeah, way back in the early days. So the sound quality is not as perfect as it is now because it's just perfect. But yeah, check out some of our back episodes. Episode 18 specifically, we talk about Bowen's reaction series, and this guy Bowen basically he reproduced some of this stuff in the lab and figured out how when you heat rocks up and what they turn into based on what they started from, and yada yada yada. So
different
check
minerals
it out.
crystallize at different temperatures.
Yeah, you get you can see fractionation in magmas, especially if they cool subsurface into plutons. But I know when I was doing my PhD, there was a grad student there who was looking at, she was doing the chemistry of these plutons, and she could see when she actually found that as this one pluton was cooling, it was injected by a second magma body that had come and basically found its way into this magma body. And so she could see this, there was this partial cooling and solidification, and then the second magma body, for whatever reason, intersected into the main magma body and started cooling then. And so you can see these two distinct chemistries within the magma.
Jeez. Wow.
It's kind of crazy.
Yeah.
Insane.
You can do with the technology these days.
Yeah, right. That's insane.
So was this all? Did she see this? Was she able to see this in outcrop, or is this all just kind of geochemical evidence she was looking at?
Just
okay.
Stuff.
Oh, okay. Cool.
Yeah.
Cool. Yeah, and so we're not going to get to all these listener questions, but we will. Do not give up hope.
Yeah.
If you've submitted a question, we will get to you eventually. Or stop asking so hard questions.
All right. What do you guys want to do? Do you want to wrap it up?
Yeah, we could. I think so.
Yeah.
Yeah, because some of these other questions are episode-ish, full episode-ish questions. So
Yeah. So we talked about that other thing. Do you guys want to do that today, or you want to wait for next week?
I say we wait till next week.
All right. Keep them coming.
I don't know. It's Jesse's thing. I was trying to save him. It's up to him.
Let's save me.
All right. Well, a little spoiler. Save him.
We'll tease it right now.
Tune in next week. We got a new segment of the show. All right.
Yeah.
It's basically, let's see how much we can watch Jesse squirm. Okay.
Yeah. Exactly.
Squirming from these questions.
Yeah.
So,
and if we're sticking with the same schedule by this time next week, I'll be, in relaxed mode because we should have off the next day.
Oh, okay.
Based on the holiday.
Oh, yeah. It'll be the day before Thanksgiving. Yeah.
Yeah. So
All right.
put it nicely. Relax mode.
All right, so we'll do that. We'll probably do that for like half an episode or so then next week. Get ready, Thornburg.
Half an episode. I say we just do a marathon and make him do it for like 6 hours. And that way we can just skip recording in December.
It'll be like his like PhD candidacy exam or something like that, you know?
God.
There you go.
Make it
Grill
end.
him for hours.
You'll just see me crying at the Thanksgiving dinner table.
How bad was that? The PhD test, candidacy
Just
exam.
long. It wasn't bad. It's just long.
Yeah.
Easy. Come on.
Make it
Yeah.
fun.
Sorry.
Say
Sorry. Mr. Non-PhD over here. Sorry.
It's just very, very long and very, you'd be surprised, very detailed oriented. A lot of very
I
detailed
mean,
oriented.
we had comprehensive exams for our master's theses.
Yeah,
I felt like they were. Yeah, I thought that was pretty in depth, pretty no joke. But then again, I never went on to my PhD, so.
Yeah, you're not missing much.
I'd still have my twinkle in my eye. I'm not dead inside, so.
Yeah, I mean, you know, you got that. So just you get
Anyway, we'd like to thank our sponsor, the Formatting Formula, again. Thank you so very much. Formattingformula.com and YouTube/C/Formatting Formula. All of our Patreons who are listening now, all of our listeners who submitted listener questions, whether we got to you or not. I'm going to, like Val and Elias and a few others. Sorry, we didn't get to your questions, but we will. So keep sending them in. I'm sure there's a bunch of others, but so I apologize. But please keep sending them in. Check us out on Twitter. Check us out on Facebook. Instagram is getting going, sort of. So all the kids now, they're on the Instagram. Nobody's watching us on Facebook anymore.
what else? YouTube, Geology Flannelcast YouTube. Check us out there. And Patreon. If you like to help the podcast out, we do have a Patreon account. You can subscribe. There's several different monthly tiers. You can do it for as little as $2 a month. Get some stickers out of the deal. If there's different tiers, and so you could hang out with all of our Patreon friends before the podcast starts. We have some fun, goof around, crack some jokes before and after the podcast. Well, before the podcast starts and after it ends, and then you get to watch the podcast get recorded live and chime in through the chat and stuff like that. And it's really cool. It's a lot of fun. Have a lot of fun hanging out with our Patreon friends. And
who doesn't want to see how the sausage is made?
There you go.
Am I right?
You can see the Flannelcast behind the scenes and just how truly chaotic it really is.
It actually takes 8 hours to record with all of our outtakes.
It's a real commitment.
Mm-hmm. So anyway, so if you'd like to help out the podcast and you have a couple bucks to spare, we have you can go to patreon.com/Geology Flannelcast, and thank you to all the people that have helped sponsor the podcast, helping us grow and helping us with some equipment updates and just kind of paying the monthly bills to keep this podcast moving. So thank you if you already have, and thank you to the future people that might want to help out as well. Or
you can give a holiday gift. Here, I've made a subscription in your name to
that's a great
Patreon.
idea, actually.
Right? What would mom or dad like more in their stocking than a little card that says, "I've contributed to a Patreon in your name." So think about it.
Yeah. If you do that, let us know. I will send a card personally.
Yeah, with a sticker.
So let's see. I think that's also geologyflannelcast.com. So all the news stories that we talk about, any of the websites we talk about on the episode, you can check out that stuff there on. We post all those links on geologyflannelcast.com. And then if you'd like to submit a listener question for a future episode, you can also do that at geologyflannelcast.com. Click on listener questions, and we'll get to your question for a future episode coming up at some point in the future, I guess. Or just click contact us. It shoots us an email. Let us say hi. Let us know where you're listening from. We love hearing all the stories from all of our friends out there that enjoy the podcast.
Where are we trending? Albania? Romania?
Romania, apparently.
Romania,
Romania,
man, we're
right
killing
now.
it. Yes. Do it.
Who would have thought? Thank you, Romania.
Yeah.
I was just looking up. We're also in Slovakia. So let me say to all our Slovak listeners, that's hello, translated from Slovak into English.
Nice.
Or Romanian, hello.
All the things you learn here on the Geology Flannelcast.
No, sorry. I have
boy. We get to omit something?
let me say Buna.
Ooh, Una.
Yeah.
I like it.
All right. So am I leaving anything out, gentlemen?
Probably, but what are you going to do?
We'll get it to next week. All right. Thanks, everyone, for listening to the episode. We love you guys, and we will see you guys next week with a brand new Geology Flannelcast. Thanks a lot, and goodbye.